Myself Dr. RPS Chauhan, Professor and Department Electronics and Communication Engineering at IMS Engineering College, Ghaziabad. I welcome you all in my new lecture, the subject of microprocessor and microcontroller. In this lecture, I am going to discuss the modes of operation, the pin diagram and the memory segmentation of 8086 microprocessor. So, the 8086 microprocessor is operated in two modes of operation, the minimum mode of operation and maximum mode of operation. So, what is minimum mode of operation? The minimum mode of operation is selected by connecting MN or MX pin to logic 1. So, whenever the microprocessor pin, that is MN or MX pin, is connected to logic 1 or plus 5 volt supply, the minimum mode of operation is selected. So, this is the first step which is required to perform. If we require to design a system in a minimum mode, we require to connect MN or MX pin to logic 1 or plus 5 volt supply. System uses only one processor in minimum mode, that is 8086 microprocessor, and this microprocessor will generate, or we can say that it is responsible to generate all the control signal for microprocessor chip. So, these in minimum mode, microprocessor is responsible to generate all the control signal for memory and input output device. In minimum mode of operation, the other interfacing device connected to the systems are the latches to demultiplex the address in data bus, transceiver, clock generator, memory and input output device. So, these are the interfacing device which are connected during the minimum mode when the system is designed under the minimum mode of operation. Minimum mode operation requires less hardware and thus it is less costly, but cannot be used in large multiprocess system. So, since in minimum mode of operation we required less number of interfacing device, so it is less costly as compared to maximum mode of operation, but this minimum mode of operation is not preferred in multiprocess system. So, this is the minimum mode of operation. So, in this minimum mode of operation, there is only one processor, that is 8086 microprocessor, and this microprocessor will generate the control signals. These are the control signals for the memory and input output device. So, here the clock generator will generate the clock input signal for the 8086 microprocessor with the basis of this clock input frequency, the microprocessor will perform the required operation. The latch, there are three latches. We know that in 8086 microprocessor we have 20 bit address bus, and out of this 20 bit address bus, the low order address bus, that is A0 to A15 are multiplexed with the data bus, and the A16 to A90 is also multiplexed with the status signal. So, in order to demultiplex this address bus, because we need to connect this address bus with the memory and the data bus to carry the data. So, it is essential that the first part is that we have to demultiplex the address bus. That is why for 20 bit address bus we required 3 latches, that is 8 to 82 to demultiplex the address, and here we get the address bus to address the memory, that is nothing but the total memory, which is 1 megabytes. If we use this A0 to A19 address line. So, with the help of this 20 address line, we can able to access 1 megabytes of memory location. So, here the transceiver, which is used to enhance the driving capability of the data bus, which is used to connect the memory device as well as the input output device. To enable the transceiver, the data enable pin is used and it is connected to output enable pin, and the data transmit and receive pin, this pin is used to control the direction whether the data is transmitted or the data is received. So, this is the dual purpose pin. If the logic is 1, so data is transmitted, and if the logic is 0, the data is received, and this is the control signal. So, here this is the minimum mode operation, and the minimum mode of operation uses only one CPU, and this CPU is responsible to generate the control signal for memory and input output device. Next is the maximum mode of operation. The important thing is that again the minimum and maximum pin is connected to ground. So, when this minimum or maximum pin is connected to ground, the maximum mode of operation is selected. In maximum mode, there may be more than one processor. It is required to remember that in maximum mode there is more than one processor. Along with this 8086 microprocessor, the another processor are the math coprocessor, that is 8087, and input output processor. A bus controller, that is 8288, is also used to generate the control signals, and in this mode which is connected to 8086 by using the status signal S2 bar, S1 bar and S0 bar. So, this 8282 bus controller is used to generate the control signal for memory and the input output device. These control signals are the address latch enable signal, data enable signal, data transmit or receive signal, memory read, memory write signal, that is memory read control signal, memory write control signal, input output read and write control signal, that is IORC, IOWC. These are the input output read control and write control signal, advanced memory write control signal, advanced input output write control signal with the help of these input S2, S1, S0. So, these are the input to the bus controller, and with the help of these input the bus controller will generate the control signal for the memory input output device. It is useful in the multi-process systems. So, maximum mode of operation is useful in multi-process system. Design is costly due to maximum number of interfacing devices are connected. So, the maximum mode operation is bit costly because the maximum number of interfacing devices are connected as compared to minimum mode of operation. So, this is the maximum mode of operation. So, in this maximum mode of operation, so here the bus controller is connected along with 8086, more than one processor is there. The function of this bus control will generate all the control signal, that is memory read and memory write, input output read and input output write control signals, some advanced control signal for memory and input output write control signals. The latches are used to demultiplex the address from the status, as well as the high order address bus are multiplexed here, and the low order address bus are multiplexed with the data bus. So, here with the help of this, the 20-bit address bus is outputted, and with the help of this 20-bit address we can able to access 1 megabytes of memory. The data receiver are used to enhance the driving capability. So, here the 16-bit data bus comes, and with the help of that we can able to access, that is give the address of 64 kilo of input output device. So, this is the maximum mode of operation. Next is the memory segmentation. Segmentation means dividing the memory into logically different parts called segments. What is segmentation? We are dividing the memory logically into the different parts. In 8086 microprocessor, we know that 20-bit address bus, hence it can access 1 megabytes of memory. So, with the help of 20-bit address, we can able to access 1 megabytes of memory, but it is not possible to work with 20-bit address as it is not a byte compatible. So, it is not possible to work with 20-bit because it is not byte compatible. It means that 20-bit is nothing but it is 2.5 bytes. So, the programmer face some problem because it is not byte compatible. So, in order to overcome this problem, to avoid working with this incompatible number, we create a virtual model of the memory. That is why we divide the total 1 megabytes memory into the 4 segments area, and these segments areas are the code segment, stack segment, data segment and the extra segment. This is the purpose, and this is the reason why we divide the 1 megabytes memory into the different segment area. The maximum size of segment is 64 kilobytes and the minimum size is 16 bytes. Now, the programmer can access each location with the virtual address. With the help of virtual address, the programmer will access the location. The virtual address is a combination of the segment address and the offset address. So, with the help of segment address and offset address, we can calculate the virtual address. Since both segment address and offset address are 16-bit each, they both are compatible numbers and can be easily used by the programmer. So, this is the reason we can access 1 megabytes of memory using only 16-bit offset address for most part of the program. So, here offset address can be stored into the segment register. The segment registers are used to hold the offset address, the starting address of the memory. That is why this is the advantage of segmentation, that it permits the programmer to access 1 megabytes of memory only 16-bit address, and it divides the memory logically to store the instruction, data and stack separately. So, with the help of memory segmentation, it is possible to store the instructions for data and the stack related operations separately, and moreover dividing code, stack and data into different segment area, it makes the memory is organized in more categorized in more organized way and prevent the accidental overwriting between them. So, in order to avoid the overwriting of one memory, the information of one memory with another, because we can organize the memory in a proper manner with the help of the memory segmentation. The physical address is calculated by microprocessor using the formula, the physical address which is a 20-bit. So, it is required to remember that the physical address is always 20-bit and it is obtained by the addition of the segment address, the segment address is present into the segment register. So, we have 4 segment register. So, this segment register will hold the segment address which is the 16 bit, and it is multiplied by the 10h, and it is added with the offset address which is 16 bit. So, with the help of this we can able to calculate the 20 bit physical address. The offset address is always present into the pointers and index register, while the segment register will hold the segment address. So, the segment address is multiplied by 10, and with this result the offset address is added to we get the 20 bit physical address. So, this is the memory segmentation. See, this is the total 1 megabytes of memory. It is a 1 megabytes, and which is divided into 4 segment area, that is the code segment area, data segment area, stack segment area, and extra segment area of 64 bytes each. So, here 64 kilobytes each. So, each segment area is 64 kilobytes. So, here the 1 megabytes are memory is mainly divided into 4 segment area. This is the segment register, that is the code segment register, data segment register, stack segment register, and extra segment register. So, this segment register will hold the starting address of the segment area of the memory. The segment address is there. So, this starting address is present into the segment register. The code segment will hold the starting address of code segment area memory. Data segment register will hold the starting address of data segment area of memory. Stack register will hold the address of starting address of the stack segment area memory. So, this way the total 1 megabytes of memory is divided into 4 segment area of 64 kilobytes each, and the segment registers are used to hold the starting address. So, this is the advantage of memory segmentation. Next is the pin diagram of 8086 microprocessor. So, 8086 microprocessor is 40 pin IC, and the pin diagram of 8086 microprocessor can be shown in this particular figure. So, here the pin diagram of 8086 microprocessor is given. The 8086 can operate in 2 modes of operation, that is the minimum mode of operation and the maximum mode of operation. For minimum mode, a unique processor system with a single 8086, and for maximum mode, a multi-process system with more than one microprocessor, that is 8086 are required. So, here the pins which are mainly used during the minimum mode of operation are hold, HLDA, write control signal, memory or input output, data transmit or receiver pin, data enable pin, address/enable pin, and interrupt acknowledge pin. While the pins which is related with the maximum mode of operation in addition to other pins are the pins. These pins are dedicated for maximum mode of operation. So, let us see the function of each and every pin of 8086 microprocessor. So, the first, that is minimum or maximum mode of operation, is selected with the help of this pin MN or MX pin. So, here it is an input pin used to select the minimum and maximum mode of operation. So, when the input is logic 1, the minimum mode of operation, or when this pin is connected to VCC, the minimum mode of operation is selected, and when the pin is connected to ground, the maximum mode of operation is selected. So, this is the meaning of that. This is the use of this pin. Next is AD0 to AD15. So, this is the multiplex address and data bus. So, here in 8086 microprocessor we have 20 bit address bus. Out of this 20 bit, the low order address is designated by A0 to A15, and this low order address is multiplexed with the data bus which is D0 to D15, which is also a 16 bit. These lines are 16 bit multiplex address or data bus. During first clock cycle, AD0 to AD15 are used to carry the low order address. This, remember that during the first clock cycle, these lines will carry the low order address, and after that this line will carry the 16 bit data. So, it will work in the multiplex mode. During the first clock cycle, these lines will carry the address, that is low order address, and after that it will carry the data. The high order are multiplexed with the status signals. So, here the high order address lines are A16 to A19. The specified address lines are multiplexed with the status signal. So, this is the function of these address lines and the status signal. So, when these lines are 00, the extra segment area of the memory can be accessed, 01 stack segment area of the memory can be accessed, 10 code segment area, and 11 data segment area of the memory can be accessed. So, this is the purpose of this particular pin. The status pins S2, S1, S0, these pins are active during T4, T1 and T2 T state, and is returned to passive state, that is 111 during T3 state when ready is in when ready is inactive. So, these pins are used by the 8282 bus controller. So, these pins are used as an input to 8288 bus controller, which are used to generate the control signal for memory and input output device. So, these pins are connected as an input to this bus controller. The function of these pins, the status signals are as follows, and it can be explained with the help of this table. So, the status on this particular pin, that is S2, S1, S0, both all are 0. So, interrupt acknowledge functions, the interrupt acknowledge function is performed, and for 001 read input output port, 010 write input output port, 011 halt operation, 100 code access, 101 read memory, 110 write memory, and when the status are 111, so it is a passive state. So, this is the function performed by the status pin of 8086 microprocessor. Next is the BHE bus high enable or S7. During T1 T state, it is low, used to enable data on most of this most significant half of the data bus. So, here the 8086 microprocessor will consist 16-bit data bus, which is divided into two parts, that is low order address bus and high order data bus, low order data bus and high order data bus. So, low order data bus is D0 to D7 and high order data bus is D8 to D15. So, when this BHE bar signal, that is 8-bit device connected to upper half of the data bus, that is D8 to D15, when BHE bar signal is low. So, this is the meaning of that. It is multiplexed with status signal. S7 signal is available during T2, T3 and T4 T states. Next is the read control. So, this pin is used to generate the active low read control signal to enable the read operation. So, with the help of this control signal, the microprocessor will enable the read operation. It will read the data from the memory or the input port. Next is the ready pin. This is active high acknowledgement signal from the memory or slower device. So, whenever the peripheral devices are connected with the microprocessor, so in order to check the readiness of the peripheral device, whether the peripheral device is ready for the communication or not, the ready input signal is used by the microprocessor to check the status of the slower peripheral. It is used to synchronize the operation of slower peripheral. So, with the help of this, the microprocessor will synchronize the operation of the slower peripherals and to perform the efficient communication. Next is the INTR pin. Interrupt request signal is sampled during the last clock cycle of each instruction. So, whenever microprocessor will perform any operation or execute any instruction, so it will check the status of this interrupt request signal on the last clock cycle of each instruction for determine the availability of the interrupt request. If any interrupt request is found pending, the processor enters the interrupt acknowledge cycle. It will enter the interrupt acknowledge cycle, that is, it will generate the INTR signal. This can be internally masked after resulting the interrupt enable flag. So, accordingly the interrupt enable flag is enabled and the processor will generate the interrupt acknowledge signal and it will serve the request of the interrupting device. Next is the NMI, that is non maskable interrupt. This is an edge triggered interrupt. It is a hardware interrupt. A subroutine is then vectored through an interrupt vector lookup table. So, whenever this non maskable interrupt occurs on this particular pin, so the processor will immediately transfer the control from the main program to the interrupt service routine. The interrupt service routine will start to the vector location. It will execute the interrupt service routine and return back into the main program. Since it is a non maskable interrupt, so processor will respond this interrupt immediately. So, in response to this hardware interrupt, the processor will generate interrupt acknowledge signal with the help of INTA pin. So, it is a active low during T2, T3 and TW. TW is nothing but the wait state of each interrupt acknowledge cycle. So, this is the acknowledge signal in response to the interrupt signal generated by the interrupting device. Next is the request and grant signal. These pins are used by the local bus during the DMA transfer. So, these pins are used during the maximum mode of operation. So, this with the help of this pin, the another processor will send the request for the use of the system bus. So, this is the purpose of the request and grant signal. So, here the request grant 0 having the highest priority, then the request grant 1 signal. So, this is required to remember, the request or grant 0 having the highest priority as compared to request or grant 1 signal. The address latch enable. So, we know that in 8086 microprocessor the low order address are multiplexed with the data bus. So, in order to demultiplex or differentiate the low order address bus with the data bus, we have the ALE signal in 8086 microprocessor. So, in 8086 microprocessor, with the help of ALE signal, microprocessor will enable the latch, that is 8282, and once the latch is enabled, then the latch will transfer the information from input to output, and these lines will carry the low order address. Once the ALE signal is low, it will disable the latch and the lines will carry the data. So, this is the use of the ALE signal. Then data transmit or receive pin. This pin is required in minimum mode system that wants to use 8286 or 8287 data bus transceiver. The direction of data flow is controlled with the help of this pin. So, this pin will perform the dual operation. When the status on this particular pin is logic 1, the data can be transmitted. So, processor will transmit the data, and when the status on this particular pin is logic 0, so processor will receive the data. So, or we can say that the data can be transmit or receive, the direction of data transmit and receive operation can be done with the help of this pin. DEN, that is data enable pin. This pin is provided as an output enable for the 8286 or 8287 in a minimum system which use transceiver. So, data enable is active low during each memory input output access. So, with the help of this data enable, it will enable the transceiver to transmit the data to and from the microprocessor or the peripheral devices. HOLD and HLDA pin hold, these pins are used for the DMA related operation. Hold indicates that another master, the DMA controller, has been requesting a local bus, that is the address bus, data bus and the control signal for the use of that. This is an active high signal. The microprocessor receive the hold request and issue the HLDA signal as a hold acknowledged signal. So, the request has been received by the processor and it can be informed to the DMA controller with the help of the acknowledged signal, that is called the hold acknowledged signal. Next is the test pin. This is examined by the wait instruction. If the test pin goes low, execution will continue as the microprocessor remains in the idle state. So, with the help of this test pin, when the status on this pin is 0, the execution is continue, otherwise the microprocessor is in wait state. And then next is the lock pin. It is an active low pin. It indicates that other system bus master have not been allowed to gain control of, when the processor is busy to perform important operation or a critical operation, or we can say that main operation. So, this lock pin is used. So, when this pin is active, so it will lock the use of system bus for any a requesting device, that is DMA system. So, this is the purpose of that. With the help of this clock input pin, the clock input pin is used. The processor will perform the execution of each and every operation on the basis of this clock input. The clock input frequency is nothing but the 5 megahertz, 8 megahertz and 10 megahertz for this different version of 8086 microprocessor. So, on the basis of clock input frequency, the processor will perform the required operation. Reset pin is used to reset the microprocessor. When the microprocessor is reset, so it will restart the resume the operation from the starting location. So, this is the use of that. This pin requires the microprocessor to terminate its present activity immediately. The signal must be active high for at least 4 clock cycle. So, it will restart the system or restart the processor, and processor will start execution from the beginning. Q status. So, these signals indicate the status of the internal 8086 instruction Q register. So, with the help of this table, we can able to give the status of information performed by the instruction Q register with both the Qs, that is QS1, QS0, no operation is performed, 01 first byte of the operation code from the Q is fetched, 10 empty the Q, and 11 subsequent byte from the Q can be fetched by the execution unit. Now, next is the physical address generation. So, physical address, as explained, the physical address of 8086 microprocessor is nothing but it is a 20 bit, and with the help of this 20 bit physical address, the processor is able to access total 1 megabytes of memory. So, this physical address can be generated with the help of the starting address, that is the base address, and this starting address of the segment register, it is multiplied by the 10h and it is added with the offset address. So, with the help of that, we can generate the 20-bit physical address. So 20-bit physical address is generated by adding the 16-bit content of segment register. So remember that in order to generate the 20-bit physical address, we require the segment register. So in 8086 microprocessor, we have 4 segment register, that is code segment register, data segment register, extra segment register, and the stack segment register. So these registers are used to hold the starting address of each and every segment area of the memory. So the segment register will hold the starting address, which is a 16-bit. The bus interface unit will append 40 to this base address or the segment address, and this resulting address is added with the offset address, which is also called the effective address, in order to generate the 20-bit physical address. So here the 16-bit offset value, also called the effective address, which is stored in the corresponding default register. So this offset address is stored into the instruction pointer register, the BX general purpose register, source index register, destination index register, base pointer register, and stack pointer register. So these registers are used to hold the effective address or the offset address, which is 16-bit, while the segment register are used to hold the segment address. Different segments have different default register for offset. For example, IP is the default offset register for the code segment. So for code segment register, IP, that is instruction pointer, is the default register which is hold the offset value, offset address. Bus interface units always append 40. So see here 40 is appended to the starting address of the segment register. So this way the 20 bits is obtained, and this 20 bit is added with the offset value, which is one of this instruction pointer, base BX register, source index register, destination register, base pointer, or source pointer register. So bus interface unit always append 4 zeros automatically to the 16-bit address of a segment register to make it 20-bit, because it knows the starting address of segment always end with the 0. So here this is the representation of the how we generate the 20-bit physical address. So here the offset value, which is 16-bit. So this offset value is either in instruction pointer register, BX register, source index, DI, base pointer, and stack pointer register, and the segment register will hold these that is 16-bit value. So the starting address of the code segment area, data segment area, extra segment area, stack segment register. The bus interface unit will append this 40. So 40 is appended. So here this is the 20-bit address, and the offset value is added with this help of this adder, and finally the 20-bit physical address can be generated with the help of this procedure. So this is the 20-bit physical address. This is the procedure to generate the 20-bit physical address for the code segment area, data segment area of the memory, stack segment area of the memory, or the extra segment area of the memory. So remember that the offset address is always present in the instruction pointer register, BX register, which is the general purpose register. This is the only general purpose register which will hold the offset address. The source index register, destination index register, base pointer register, and stack pointer register. All registers are the 16-bit registers. These registers are used to hold the 16-bit address, and the segment register will hold the offset segment address of the memory, starting address of the segment area of the memory, and these 40 appended by the bus interface unit, and finally after addition we get the 20-bit physical address of the memory. Thank you very much.